All right, welcome. Moving on to section 1.4, we are talking about angles now. So we're introducing angles. This is probably something that you've seen before. However, if it's not, that's totally fine. So what an angle is, and we have a picture of one, down here, is it is a figure that's formed by two rays with the same endpoint. All right, so here we have ray BA and ray BC. They have the same endpoint at B, obviously, and as they kind of go off in their separate directions, they create this angle right in here, and we measure those angles. And so in this case, a couple of definitions. These are not super important to know. These rays are known as the sides of the angle. Okay, these are the sides. So ray BA and ray BC, those are the sides of the angle. And then this point B right here, that is known as the vertex. Okay, the end point of both of those rays is known as the vertex. So now when it comes to naming angles, this is really important. This can be a little bit tricky. There's two different ways to name an angle. First, we can name it using 3 letters. The important thing is, all right, I guess I did not have to sneeze. The important thing is that middle letter needs to be the vertex. So we could call this angle ABC. Okay, and to denote that it's an angle, we throw this little sign out in front that looks like a little miniature angle. So we could call this angle ABC. If we wanted, we could also call it angle CBA. We can't call it BAC or BCA because B has to go in the middle. Okay, B is the vertex. It's got to be in the middle there. Also, sometimes we'll see this small little number in between. And so we could just call that angle 1 as well. That also works. And also, for this problem, and this will work for this problem, but possibly not other problems, if it's a stand-alone angle. So in this case, this angle is really all by itself. Okay, we can just call it angle and then give it the vertex's name. So we could just call this angle B. That also works. Okay, angle B would also work. However, over here, I can see that I clearly have multiple angles. So I can't call any of these angle O, because if you just say angle O, well then I have no idea which one you're talking about. O is the vertex for 3 different angles. It's the vertex for COB, COA, and BOA. So angle O would not work over here. You would have to say, all right, I have angle COB or BOC, right? That's the same exact thing. I have angle BOA, or again, angle AOB is the same exact thing. Or you could say that you have angle COA or angle AOC, which is the same exact thing. All right, so over here, we're allowed to call it angle B just because it's clear to see which one that refers to. That is the vertex of only one angle, so then it's fine. However, when it's the vertex of multiple angles, you really are not allowed to do that because nobody knows which one you're talking about. All right, angle measure. So maybe you guys have seen a protractor before, maybe you haven't, but this is what angle measures generally look like. So a 0 angle is if we just have 2 rays that are lying directly on top of each other. There's no angle. And then we slowly increase until we get maybe one of those angles is directly vertical. One of those sides is directly vertical and the other one is directly horizontal. Okay, so right here, boom, we have one side, this angle XOV right here. Okay, angle XOV, that is what's known as a right angle. It's 90 degrees, okay, 90 degrees when there's one horizontal and one vertical. Okay, they're also known as perpendicular. We'll talk about that a little bit later on in the year as well. And then we continue going. Once we get to just a straight flat angle, This here is 180 degrees. That is known as a straight angle. That's 180 degrees. So if we have opposite rays, right, rays that have the same endpoint, OX and ray OZ, they have the same endpoint. They're going in opposite directions. They make a straight angle. That's 180 degrees. Okay, now for congruent angles. Well, congruent angles, very similar to congruent segments. Congruent segments have the same length. Well, congruent angles have the same measure, okay? The same angle measure. Okay, same measure. So let's say here's a couple of congruent angles, and we mark them as congruent. You'll see like a little line in there that tells you that they're congruent. As long as it has the same marking there. I'm actually going to erase this one just a little bit. I want you to see that it would have the same exact marking. So angle 1 is congruent to, oops, I called them both angle 1. Okay, I'll change this one here. This one is angle 2. If it has the same marking on the inside of the angle, that means that they are congruent. Okay, it tells you that they are congruent. And so then we could write it out. We could say angle 1 is congruent. Angle 1 is congruent. We'll use that congruent sign that we learned. It's just an equal sign with a squiggly above it. So we could say angle 1 is congruent to angle 2. Or we could say that measure of angle 1 is equal to measure of angle 2. All right, so when we talk about the measures of angles, we put just an M right out in front of that angle symbol. So it's the measure of angle 1 equals the measure of angle 2, or angle 1 is congruent to angle 2. All right, just like with segments, it's very important. You can't say that two angles are equal. You can say their measures are equal, or you could say, and you can also not say that their measures are congruent. Okay, their measures are not congruent. The angles themselves are congruent. All right, so some different types of angles now, and you guys maybe have heard these before. An acute angle, these are kind of the smallest angles that you're going to have. They measure between 0 and 90. So an example is an angle right here. Okay, a right angle. A right angle has a measure of 90 degrees. So think of one vertical, one horizontal. They make almost like a square. Okay, it's nice and square. You're going in one direction and then boom, you turn straight to the left. Okay, that's a 90-degree angle. An obtuse angle measures between 90 and 180. So an example of an obtuse angle would be an angle like this. And then finally, a straight angle. A straight angle, remember, is just with opposite rays. It looks like just a straight line. Those are equal to 180 degrees. All right, adjacent angles now. The way I like to think of adjacent angles is they're really just angles that are directly next to each other. They don't overlap at all. They're just directly next to each other. The formal definition is they share a side and a vertex. So they share one side and the vertex. But they do not have any common interior points. And I'll explain what an interior point is in a second. They do not have common, do not have a, oops, I put that in the wrong spot. They do not have, that doesn't make sense. They do not have a common interior point. Okay, an interior point, guys, is just one that falls on the inside of that angle. It falls between the two sides. So if I have an angle right here, this is going to be an interior point. This is an interior point, interior point, interior point. Okay, they fall on the inside of that angle. If you were to extend those rays forever, they have to fall on the inside. So here we have a couple of examples. 1 and 2 are adjacent angles in both of these examples because they clearly just sit right next to each other. if in this example we had, let's say, angle 1, here we have angle 2, and then this one here is angle 3, this big one is angle 3. Angle 1 and angle 2 are still adjacent angles. However, angles 1 and angle 3, because they share a common interior point, they are not adjacent angles, okay? Even though they share one side, they also share a vertex. Unfortunately, they share a common interior point. Therefore, they are not adjacent angles. Same thing with 2 and 3, okay? They share a common interior point. All right, so they just think they have to be next to each other. All right, moving on to angle addition. And again, this is very similar. We talked about segment addition in our last video, in our last lesson on segments. Okay, in this case, if we have two angles, two smaller angles that make up a full angle, we can add those together to get the full angle. Say, for example, I know that this small angle right here is 20 degrees. I know that this one right here is 30 degrees. And I want to find, well, what's this big angle, right? What's this angle right here that combines the two of them? It's just 20 plus 30, okay? We're just going to add those together and get, all right, this has to be 50. So in the case of this drawing right here, we could say that measure of angle 2 plus measure of angle 3 has to be equal to the measure of, well, what angle do they make up? Remember, we can't just call it angle E. They make up the angle RET. So that's equal to the measure of angle RET. Finally, on our last slide here, we have an angle bisector. Well, a segment bisector, we know, passes through the midpoint of that segment, so it cuts that segment in half. Well, an angle bisector does the same thing. It cuts an angle in half. Okay, we're going to cut an angle in half. All right, so in this case, we see ray YW clearly bisects angle XYZ because it cuts it into two equal parts. Okay, so ray YW is an angle bisector of angle XYZ. It cuts that big 60-degree angle in half into two 30-degree angles. So ray YW is an angle bisector of angle XYZ. All right, hope this helped you guys out. Enjoy the rest of your day.